This is Sharma solution, class 12, chapter 6, Determinants, MCQ, multiple choice questions. Now, in the MCQ, there are always 4 options, and we'll choose one of it. And in some cases, there may be more than one, they are true. So, if A and B are square matrices of order 2, then determinant of A plus B is equal to 0 is possible only when. So let me tell you, the answer is a D, and this is quite obvious. Why? You can do all way to interpret it and to analyze and show it. But when we have A and B, and when we add them, and then we take the determinant of it to be 0, that is only possible when A plus B is 0. If A is 0, B might have some value. If B is 0, A might have some value, right? So, getting together A and B, when it adds up, then if it is 0, then only the determinant of A plus B has to be 0. It will be equal to 0. If both are zeros, then also 0. If one is A, say B is equal to minus A, then also the thing remains same, A minus A is 0 or B minus B equals 0. So here the logic goes that A plus B, this has to be equal to 0, then only the determinant of A plus B equals 0 is possible. Now you can understand it like this also. You can have A and B different square matrices of order 2, and when you add this and then take the determinant, and if a determinant is 0, that means this Aij plus Bij equals 0, and that means it has to be 0. Addition of each element has to be 0. Which of the following is not correct? So let me tell you, the answer is D, because it is not correct. The others are correct. So first let me understand or make you understand the D one. So when we open it, it's just not A plus B can be written as just all these addition can be divided into 2 matrices. It's not like that. You have to open it 4 times. So A plus B, E plus F, C plus D, G plus H. So how are you going to open this? This is only possible when we do AE separately and then BF separately. Rest will remain same. C plus D, G plus H will remain same. C plus D and G plus H will remain same here. Then now we have to open this C plus D and G plus H. Same logic goes. ACCG and AECG and AEDH. So this has to be opened into 2, AEDH, and the next one also, BF and CG and BF and DH. Okay. So this is incorrect. Now A and A transpose, if you take the determinant of A or A transpose, they are same, right? They are same. Rows and columns are only changed, so determinant will not change. Determinant is actually the value of the matrix. We already saw that Ka, when we take K outside, it will be K to the power n. Since this is 3 by 3 matrix, it is K raised n, and then we have determinant A inside. Third one is, if A is a skew symmetric matrix of odd order, then the determinant of A is 0. So odd order, if the matrix is of odd order, then the determinant of A will be 0. Now A is this matrix, and the Cij is the cofactor of Aij in A, then the value of determinant of A is given by. So A11, C11. Always remember, the cofactor of A11, that is the C11, is multiplied to the value. But others are A11, C31. No, it's incorrect. Only B and D seems to be correct. But still, A12 cannot be with C21. It has to be with A12 and C12. So the D1, A11, C11, 2121, 3131, this is correct. So the answer is D here. Please remember, the subscript has to remain same. For example, A11, the cofactor is C11. For A12, it has to be C12. A13, it has to be C13. Okay. Now, if one more thing, let me tell you, if we take the row and the cofactor of the other row, and then you apply this, it will be 0. So cofactor of another row or a column with that row or different row will be 0. Which of the following is not correct in a given determinant of A, where A is equal to Aij, and this is 3 by 3 matrix. So which one is not correct? Now the answer here is B. Minor of an element can never be equal to the cofactor of the same element. See, minor and cofactor, they are just equal with the sign. What I am trying to suggest is cofactor is just a minor with this sign, and the sign depends on minus 1 to the power I plus j. I plus j is the I and j are the row number and the column number. Okay, so the minor of an element will be equal to, half of the minor will be equal to half of the minor will be equal to cofactor, half of the minor will not be equal to cofactor, because there is a slight change in the negative sign. Okay, so if you take a 3 by 3 matrix, wherever we have minus 1 to the power even, then minor and cofactor are same. Whenever we have minus 1 to the power odd, I am talking about I plus j, row number and column number. When it is I plus j, when it is odd, then the minor and cofactor will not be equal. Only the difference will be the negative sign. Minor will be equal to negative of cofactor and vice versa. Now coming to the first one, order of minor is less than order of determinant A, and this is absolutely correct. The value of the determinant is obtained by multiplying elements of row or column by corresponding cofactor. This is also true. We have just seen in a previous question. So we take the row and we take one by one the cofactor of that element of that row or a column. Okay. Now order of minors and cofactors of elements of A is same. Order of minors and cofactor of the element A is same, and this is same because minor cofactor has no change. Only the signature is that is a sign is same. Let this is an expression or an you can say an equality. Then the value of 5a, 4b, 3c plus 2d plus e. So we have to find out the value of a, b, c and d and e. If we are able to find out the a, b, c, d, e value, then we can apply it here, use it here, and then we can find out the value. So since we have an equality, we'll open this left determinant and then we'll try to equate it with the right one. And then we'll equate the x to the power n coefficient with the x to the power n coefficient on the either side. We'll equate that. So either you take the left one and try to put some properties and solve it, or you can just open it. So when you open it, see, you can easily get first column, second column subtraction, first column, third column subtraction, or the rows, first, second, third, you will get various zeros. But rather than going to the detail, because this question is a bigger one, so let us open it using the first row. What do you get? X. What will be the minor here? X6, X6. Two rows are same, so it will be 0. Then minus 2, it will be x square x and 6, 6. X square x and 6, 6. Okay. Then we have the third one, plus x, and then you get x square x, x, x. X square x, x, x. So what is this? X, 6x minus 6x, it is 0, leave it. This is 6x square minus 6x. Then you have minus 2 outside. Plus this will be x cube minus x square. So we have x cube minus x square it will be. So let us open it. Minus 2. So minus 12x square plus 6 to the 12x plus x to the power 4 minus x cube. Now let us arrange it with the descending power of x. So x to the power 4, you write it here, x cube, so it is minus x cube. Then we have minus 12x square, so write minus 12x square. Then you have 12x plus 12x plus this is 0. A is 0. So A is, x is A, so 1, coefficient is 1. B is minus 1 and C is 12 and D is 12. C is minus 12 because it is minus 12 here. It is minus 12. So let me just change it. It is minus 12. So C is negative 12, D is equal to 12, and E is of course 0. Now you have A, B, C, D, E value. You all got all value you have got. Now 5 into A, that is 5 into 1, plus 4 into B, B is negative 1, C into 3 into C, C is minus 12, negative 12, then 2 into D, D is positive 12, and E of course is 0. So this is going to be minus 11. The value of the determinant is independent of. So it may be independent of n or x, because A is a constant. There are only two variables, x and n. So let us open it properly. And then before that, assume this, say nx to be A, nx to be A, n plus 1x to be B, n plus 2x to be C. So you have A square A1 cos A, cos B, cos C, sin A, sin B, and sin C, right? So let us open it, and there will be an expression you need to remember, that cos A sin B minus cos A sin B minus sin A cos B is equal to sin A minus B. So I am just opening it, A square using the first row. So you get A square cos B cos C sin B sin C minus A. You get cos A sin A. Then we have cos C sin C plus 1. And this will be cos A sin A and cos B sin B. Okay. Now this is A square cos B sin C you can write, minus cos C sin B you can write, minus A cos A sin C, minus cos C sin A, plus 1 into cos A sin B minus sin A cos B. Cos A sin B minus sin A cos B. Okay. Now we have an identity, we have an equation here. So this equation is cos B sin C minus cos C sin B. Just assume that it is say cos A sin B minus sin A cos B. So it is sin A minus B. Please remember. So since we have B and C here, or C and B here, so you can write it as sin C minus B. So A square sin C minus B. Second one will be minus A sin C minus A. This is sin C minus A plus sin B minus A. So sin B minus A. Okay. Now we have assumed A, B, C. Now we have to subtract it. Let us see C minus B. What is C here? C was n plus 2x. What was B? It was n plus 1x. So C minus B is n plus 2x minus n plus 1x. So you can take x common, n plus 2 minus n minus 1. So n gets cancelled, 2 minus 1 is 1. So you get x here. So n is not there, remember? And please, try to see that there is no n here. Similarly, C minus A will give you 2x. B minus A is going to be x. Just subtract these because we already assumed it. So I'm just subtracting is n plus 1x minus nx. So when we have n plus x minus nx, it will again be 1. Or you can say x. Again, the n is not there. In all of these, you'll get a square sin x minus a sin 2x and this sin x. So finally, we can conclude by saying this, that this is actually independent of n. There is no n here. So what will be the answer? The answer is A. This is the answer. Now we have two determinant. And these two determinant, there are certain things which are given. Adding of these two gives 0. 1 is equal to 0. Or 1 plus twice of second is equal to 0. None of these. What we'll do here is, because we have already done this type of question while we were doing the exercises, and this second one you take and see, this second one we have already done. So I'll just show you how we can make it as the first one. So I'm just writing it 1 BC, CA and AB. Then we have ABC. So ABC multiply ABC divide. So I am taking A, multiplying it with the first row, B multiply with the second row, and C multiply with the third row. So in the first row we get A, B, C and A squared. Multiplying this with B now, second row with B, A, B, C and B square. Multiplying this with the third row. So what do you get? C, A, B, C again, and then C square. Now let us take A, B, C common from the second column. So already A, B, C was in the denominator, so just cancel it. So you get A, B, C, 1, 1, 1 and A square, B square, C square. Now just change the column 1 to column 2. It means exchange column 1 and column 2. And we remember always that when we exchange two rows or two columns, that means we have a negative sign outside. Column 2 and column 1 we are exchanging. So 1, 1, 1, A, B, C, A square, B square, C square. So this negative was there. Now since these two are still not same, but we know that the transpose can be done. If the rows are changed into column, that is A transpose, if we take the determinant, then when we equate it, so the determinant of A is equal to the determinant of A transpose, right? So now you can just transpose the rows and column. Since negative sign is already there, 1, 1, 1, this column I'm making it as row, A, B, C I'm making it as a row, A square, B square, C square I'm making it as a row. Okay. Now negative sign I'm putting it in front. So what do you get? Since determinant of 1 we can write directly write 1A, 1B, 1, 1, 1, A, B, C, A square, B square, C square, and these two are same. So you subtract it, it is going to be 0. Now this question where D sub k, that is the subscript, and we have a determinant, and when we sum these, or you can say k goes from sum 1 to n, and we start adding this D determinant 1, then we put 2, then we put 3, and we keep on adding it like D1, D2, D3. K, in place of k you have to replace 1, 2, 3 like that. And if this is equal to 48, then what will be the value of n, so that this addition is equivalent to 48. So let me resolve these first, and then we'll try to solve this. And these are different rows, so we have 3 rows and 3 columns. So what we'll do is, first we'll do row 2, we'll change row 2 to row 2 minus row 3. I'll show you how this will be done, row 2 minus row 3. So this will be 2k minus 2k plus 1. First one I'm showing you, just to know that how it will be done. So it will be 1. So the first element of the second row will be 1. Then we have other values. Okay. For example, row 2 minus row 1 is n square plus n plus 2 minus n square. So n square will get cancelled. And what will be there? It will be only 2 will remain. N square plus n plus 2 minus n square. So n plus 2 will remain. Right? Now coming to the third one, that is R2 minus R3. So n square plus n minus n square minus n minus 2. So minus 2 will remain. All these are very important because the later discussion will involve this. Now second step is to change the row 2 to row 2 minus row 1. The row 2 to row 2 minus row 1. So we have this 1 and n. What was remaining? 1, 1, 1, 1 n plus 2, 1 n plus 2 and minus 2, and the third row is 2k minus 1 n square and n square plus n plus 2. Now we are applying R2 minus R1. R2 will be changed to R2 minus R1. So let us see what will happen. So this row 2 minus row 1 we are doing, 1 minus 1 will be 0. N plus 2 minus n will be 2. And this is n plus 2 minus n. That is going to be 2. And then minus 2 minus n. This will be minus 2 minus n. Okay, the final thing which will come after doing R2 minus R3 and giving it to R2, and R2 minus R1 giving again back to R2. So this D sub k Why k? Because k is a variable here. So what will remain? 1 and n. Second we already changed. So let me just write that value, which is 0, 2 and minus 2 minus 1. 0, 2 minus 2 minus n. Then we have the third row. It will be 2k minus 1 n square plus n plus 2. So d sub k. Now when we add it, when we do this sigma here, so k equals 1 to n we have to do. That means we'll put k as 1, whole determinant. Then we'll put k as 2, k as 3, and then we go on and on till this k is n, and we add them and equate it to 48. I hope you got the idea. K is going to vary, other value remains the same, so the expression will be in terms of n, because k you are actually changing the value. So I am writing d sub 1. In place of k we are putting k as 1. It will be 1, 0, and k is 1, so 2 into 1 minus 1, that is going to be 1 here. And rest, this n, this will be like this. Only k will be 1, okay? Rest all will remain same. Now we have to add it with what? Because now k has to be put in as 2, then 3, like that. So I am now placing in place of k equals 2. So 1, 0, k is 2. So 2 to the 4 minus 1. And that is going to be 3. N to n square, n minus 2 minus n, and n square plus n plus 2. So this is going on. This goes up till n. So this final value will be actually 1, n. It will be 2n, k will be 2n minus 1. That is the only replacement here. Okay. Now let us compute this first one. And you will see an analogy here. Only this first column we are going to use, means the first column we are going to open only the things which will have the analogy, you will just see. So I am opening the first one with 1, 0, 1. So 1, this will come, then 0 I am not writing. It will be minus 0 something, I am not writing. And then we have plus 1. And then that will be n2 and n minus 2 minus n. Minus 2 minus n. Okay. Now when we compute this, what are you going to get? 2 into n square plus n plus 2, and minus minus will become plus, so it will be plus n square into 2 plus 1 2 plus n. This is not minus, this is plus, so I'll just change it. Plus the next part, plus 1 into, it will be minus 2 minus n into n, and plus multiplied by minus 2n. Now this we have got when we put n as this k as 1, and the first determinant we have opened. Now the second determinant when we open, everything will come same. That is the first 1 into something, because we are opening it using first column, 1, 0, 3 will be there. So first thing will remain like this, 2 n square plus n plus 2, and plus n square 2 plus n. This is not negative, this is plus. I'll just change it in a while. Now this is analogy. You have to see the analogy, how they are similar. So this will be same thing. There will be 0 also, 0 multiplied by something, I'm not writing it. It will be same, plus n square 2 plus n. As I just suggested, it is not minus, plus, I'll just change it. Plus, now previously it was 1, and now it will be 3. 3 into this 3n, and then minus 2 minus n, and minus 2n. This will be. So 1, 3, next will be 5. 2k minus 1, if you put k as 3, 3 to the 6 minus 1 is 5. It will be 2n square plus n plus 1 plus n square 2 plus n and plus 5n. Same thing I'm writing. Minus 2 minus n and minus 2n. Now you see, this is k equals 1, this is k equals 2, this is k equals 3. So this will go on and on till n. When you put k equals n, this will go on and on. Right? So what will be the last one? This will remain same, it will not change. 2n square plus n plus 1 plus n square 2 plus n plus 1, 3, 5, and this will be n. So n minus 2 minus n minus 2n. Now, when we add them, this also have to be added because there is a sigma. If you add 1, 1, 1 n times, the result will be n. So when you do this, if you add anything which is similar n times, so that summation will be n times of that particular single value. So this whole will be 2 into n square plus n plus 1 plus n square 2 plus n will be n times 2, same thing, just multiplied by n. So 2 n square plus n plus 2, then we have plus, as I said, this is not negative, I'll just change it to plus. This will be plus n square 2 plus n, right? So let us do it. I'm just rechecking it so that, as I said, since it is when we open this with 1, the first one, it was actually minus came outside and we made it as plus, right? Okay. So this is cross multiplication simply and plus will come. So as I was just suggesting, the same value, if it is going for n times, or if we are adding it for n times, n times, the result will be single value multiplied by n. Okay, this is the first value. Now coming to the second part. The second part is 1, if I take this n into minus 2 minus n minus 2 and this if I take common, and if we add all of these, which you see here, so I'm just taking this and then I'm taking this common also. So what will remain? 1 plus 3 plus 5 till n. 1 plus 3 plus 5 till n. And the summation of 1, 3, 5, all the odd numbers, 1, 3, 5, odd natural numbers you can say, it is nothing but n square. So we can replace this 1 plus 3 plus 5 till n as n square. So I'm replacing it by n square. Okay, this whole has come. Now can you open this? Now you just have to open all of these. So when we open this, there will be some addition, there will be some cancellation, there will be some combination correction. I hope you will be able to do. I just don't have enough space. So everything you have to multiply, like n square, I'm showing it. N square with 2 and then n square with also inside whatever you see here. So multiply and just resolve. So what I'm trying to give you here is, I'm just clearing it. And the final thing I'm going to give, the final will be 2n square plus 4n. So let me just show you here. When you open this, I told you 1 plus 3 plus 5 plus 7 plus n was n square. And we just put k equals 1, then 2, then 3, like this goes till n, and we add it. So when we open this, we get 2n square plus 4n. So 2n square plus 4n is equal to 48. 2n square plus 4n minus 48 equals 0. Just divide it by 2n square plus 2n minus 24 equals 0. Now 6 4 is 24. So this 2 can be written in terms of 6 and 4. N square plus 6n minus 4n minus 24 equals 0. So n you can take common, n plus 6, and minus 4 you can take common from here, and that will come as n plus 6. Here n plus 6 minus 4 n plus 6 equals 0. So n plus 6 and n minus 4 will be the factor. Either n minus 4 is equal to 0, that is n is 4, or n plus 6 equals 0 and n equals minus 6. But since n cannot be minus 6, it is going from 1 to n, right? So we discard this n equals minus 6 value. We will take n equals 4, right? N is equal to 4. Now this one, we have just did a question like this in this exercise. So this expression be an entity in x where a, b, c, d, e are independent of x. Then the value of e is, so what is the value of the constant basically? Everything is there from x to the power 4 till x to the power 0. And what is the constant x to the power 0? That is e. So what we'll do here is we'll just open this determinant, or we'll solve this determinant. And since we are not applying any properties, I'll show you here only. I hope you'll be able to do, because this we have done a number of times. So the final expression, I hope you'll be able to do it. And we are opening it using the first row. So first row is x square plus 3x, x minus 1, and x plus 3 we will use. and they will be multiplied by the minor, their minus, their respective minors. So the final thing is that you will get an expression. I hope you will be able to do this. This is the final expression. Now I want you to compare it with ax4, bx3 and cx square and dx plus e. So I'm equating it using this. So when you equate this, see x to the power 4, so a is minus 7, x3, b is 22, c is 32, d is 27. What is constant? Constant is 0. There is no constant term here. So the answer is 0. B is the correct answer. Using the factor theorem, it is found that a plus b, b plus c plus a are the three factors of determinant this. The other factor in the value of the determinant is. So in order to solve this, we have to use a plus b plus c plus a. So everything we have to write in terms of this a plus b plus c plus a, because they are already given as the factors of this determinant. I hope you got the idea that a plus b plus c plus a is important. So a plus b, let us say, because a and b is there, let us say it is 2c. It is twice. You will just know why we are writing it as 2c. What is b plus c? B plus c we can write it as 2a. B and c on the other left hand side, a will on the right hand side. Why I am writing it, you will just know. Now what about a plus c? So a plus c will be 2b. And this a, b, c on the right hand side, we have just taken it capital just to have a difference between the smaller ones and the capital ones. Right. Okay. We'll use it later. So I'm using this, the left hand side and the right hand side, and adding them. It will be a plus twice a, twice b, twice c. Right also twice a, twice b, twice c. So just take 2 common from there. So a small a plus b plus c will be equal to capital A plus b plus c. Right? Now we can write a in terms of this. What is a? A plus b plus c minus b plus c. Right? You can write b and c gets cancelled. What is a plus b plus c? We just saw that it is capital A plus capital B plus capital C. So capital A plus B plus C minus, what is B plus C? I just told you it is twice A. Assume it to be twice A. So A plus B plus C minus 2A, A gets cancelled. It will be B plus C minus A. So B plus C minus A, this is for A. Similarly, we can find out B and C. B is C plus A minus B, and C will be A plus B minus C, all in capitals on the right hand side. Now you see, this we have started, and we will write this in terms of capital ABC. Right? So first one is minus 2A. So I'll just show you how to do this minus 2A so that you will be able to do by yourself minus 2B and minus 2C. And then B plus A plus B, C plus A, we already imagined it. We have already said this is what 2C, 2B, 2A will be. So minus 2A I'm going to just show you. Minus twice, what is A? In place of A, you can write B plus C minus A. Now multiply it here inside. It will be minus 2B minus 2C and plus 2A. So it will be 2A minus 2A minus 2B minus 2C. Now you can take 2 common. 2 was already common. So this is twice A plus B minus C. So this is how we'll write this. Minus 2A is A minus B minus C. Twice of this. And in place of this minus 2B, you can write 2B minus 2C minus 2A. In place of minus 2C, you can write 2C minus 2A minus 2B. Right? Okay. In place of minus 2A minus 2B minus 2C, we have written all of it. In place of B plus A, C plus A plus B, we will have to write 2C, 2A, 2B. Okay. Now, why we require it? Now you see, in row or column, you can take 2 common. You get 2 common either from the rows or the column. So 2 into 2 into 2, that is going to be 8. So 8 you have taken common. So this whole will change column 1 to column 1 plus column 2 and column 2 to column 2 plus column 3. So column 1 will be changed to column 1 plus column 2, that is this C. If you add A minus B minus C, C gets cancelled, A minus B. If you add B minus C minus A, C gets cancelled. Similarly here, C2 plus C3. A plus C minus A minus B will be A gets cancelled, C minus B. So finally what you got? We have got this one. Now we'll apply row 1, row 2 will be changed to row 1 plus row 2. And row 3 will change to row 2 plus row 3. We already changed column 1 to column 1 plus column 2, column 2 to column 2 plus column 3. Here we are going to change row 2 to row 1 plus row 2 and row 3 to row 2 plus row 3. So what do you get? Finally, final value I'm going to tell you. A minus, this is the final value, and 8 of course was there. We just wanted maximum zeros here actually. Now what we do here is, we open it using the first column. So A minus B, 0 I'll leave, and this will be twice of B. So A minus B and twice B. So A minus B, this, just write the cofactor, no, minor here. So when we just open this, we get 32 into A plus B plus C. 32 into A plus B plus C. So 16 we have taken, and 2 will come outside. Only ABC will remain 32. Capital A, capital B, capital C. But A, capital B, capital C, this you have chosen, you have written. The question is only asking about small a, b, c. So now we'll replace capital A by what? Capital A by B plus C by 2. Capital B by A plus C by 2. Capital C by A plus B by 2. 32 was there, so we have 2 in the denominator, 8, so 8 4 is 32. And what we got? A plus B, B plus C, CA. A plus B, B plus CA was already the factor of the determinant. It is already given in the question. So we have 4 remaining. So 4 is the other factor of the determinant. Got it? It's a tricky question. If it will come in 5 marks, I hope. If A, B, C are distinct, then the value of x satisfying this is equal to 0. So now you see, if you put x equals, say 0. If you see x equals to 0, this matrix or the determinant is going to be skew symmetric. I am putting x as 0. So 0 minus A minus B, A 0 C, and B minus C 0. B minus C 0. Okay. Now this we got when x is 0. This one, this particular matrix you can call it, or a determinant you can call it. Determinant is actually the value of the matrix. So you can call it as matrix also. Now this matrix, if you take the transpose of this matrix, it will be the negative of A. That means that this matrix is a skew symmetric matrix. That is, if you take the transpose, A transpose, it will be negative A. Let us see. Let us, row and column I am just changing. 0 minus A minus B, this I am making as the column. So 0 minus A minus B. A 0 C I am making as a column, A 0 C. B minus C 0 I am making it as a column. And now let us take negative common from here, negative 1. So when we take negative sign, it will be 0 minus A minus B. This will be A 0 C. This will be minus B C 0. Minus B minus C. B minus C 0. So A transpose is equal to negative A. So what does it mean? Skew symmetric. It is skew symmetric. And when you know in its skew symmetric matrix, if it is of say 3 by 3 order, if it is odd, then the determinant will be 0. So the determinant of this matrix is 0 because of it. Okay. If the determinant thus is equal to 0, then whether ABC is in HP, that is harmonic progression, geometric progression, arithmetic progression, or ABC are in GP, and one of the expression also, alpha is the root of this expression. So what we'll do here is, see, we'll change the column 1 to column 1 minus column 2. What is the benefit? We have AB, 2A alpha plus 3B. Then we have BC 2B alpha plus 3C and 2A alpha plus 3B and 2B alpha plus 3C and 0. So this column 1 I am changing to column 1 minus column 2. Column 1 minus column 2. What is the benefit here? You will just see A minus B, B minus C. When you subtract here, you get 2A alpha plus 3B minus 2B alpha minus 3C. So 2A alpha minus 2B alpha is, you take 2 alpha common, A minus B. Plus 3 you take you common, B 3, B minus C. So you have A minus B also and B minus C also. And 2 alpha A minus B plus 3 B minus C. And what is remaining? BC 2B alpha plus 3C. And here you get 2A alpha plus 3B and 2B alpha plus 3C and 0. Now if you multiply the first row with 2 alpha and multiply the second row with 3, and if you subtract it with the third row, then you will get a 0 here, right? So we are changing the row 3 to row 3 minus twice of 2 alpha of R1 minus 3 of R2. So twice alpha, please remember it is not 2R1, it is 2 alpha R1. So A minus B, B minus C is already there. So 2 alpha, let me write it 2 alpha here and 3B minus C. So 2 alpha and that will be subtracted. So you get a 0 here. Similarly, if you have done this, you have to do it for all of this. So B is multiplying 2 alpha with B and multiplying 3 with C and subtracting it with 2B alpha and 3C. So what do you get? You again get a 0 here. So BC, so 2B alpha plus 3C minus 2B alpha minus 3C. So get a 0. Okay. Now this is 2A alpha plus 3B and you get 2B alpha plus 3C and 0 minus, now this, because you have to subtract it. So you get all of it, the first two element of the third column in negative. So with 2 alpha, so minus 2 alpha, 2A alpha plus 3B plus 2B alpha plus 3C. Okay, let us open it. That is the third row. We are opening it. So only the last element of the third row will be there. And the cofactor will be A minus B, B minus C, BC. Right? So let me just write it here. Minus 2 alpha. Then we have 2A alpha plus 3B. And then we have, I'm taking minus inside. So let it be minus. Minus 3, 2B alpha plus 3C. And this will be, see, let me just show you here. It will be this will be on the next element. So let us solve it. A minus B into C minus B minus C into B. C minus B into C minus B into B minus C. So you get CA minus CB minus B square plus BC. So this BC gets cancelled. You get CA minus B square. So either these are two elements. So either CA minus B square is 0, that is B square equal to AC, that is ABC are in GP. ABC are in GP, what does it mean? B square has to be equal to AC. Or the other element, this element. If you take this, you will get a proper expression 4A alpha square plus 12B alpha plus 9C. So this can be 0. If omega is a non-real cube root of unity and n is not a multiple of 3, then this determinant, what is the value of this determinant? So non-real cube root of unity. So either you add the 3 rows or either you add the 3 columns. The answer will remain same. So we are adding column 1 and column 2 and column 3. You can do it for row 1, row 2, row 3 also. So 1 plus omega raised n plus omega raised 2n And similarly here also you will get 1 plus omega n, n, but we know that 1 plus omega square is what? It is equal to 0. But what we are getting here is, in the first row, first column, we are getting 1 plus omega raised n omega 2n. Let us put n equals to 1. It is 1 plus omega square. It is equal to 0. Now put n equals to 2. 1 omega square, omega 4. Omega 4 is what? Omega cube and dot omega. So omega cube is 1. So ultimately omega 4 will become omega only. So 1 plus omega square, the same thing will come. So it can be 3 or 3, it can be anything other than 3 multiple. So since question is saying it is not a multiple of 3, the first column will give you 0, 0, 0. So when the column whole is 0, the result will be 0. Now the next one is AR is given, A sub R, that is the subscript. Now we have to find out the sigma. Sigma is addition. R equals 1 to some n, AR. So let me give you an answer here. The correct answer is actually, I'll just show you. It's not minus 2n, it's actually something else. So sigma means it's addition. If you are adding everything, you have to add the internal element also. So one by one you need to know what is sigma. Sigma 1 is what? If you add 1 n times, it will be n. 1 plus 1 plus 1. This is going to be n. If it is n times, it is n. So it is going to be 1. Only the r term and constant term we will add. Other won't change. Because we are doing it for r. What is 1 plus 2 plus till n? It is n plus 1 by 2. Okay, n plus 1 by 2. So sigma r is n plus 1 by 2. What is sigma 2 raise r? R equals 1 to n. 2 raise r is 2 raise 1 plus 2 square plus 2 cube. It goes up to 2 raise n. So the summation we already know. We already done in the previous classes. We have to take s, then 2s will add. So finally 2s minus s will give you 2 raise n plus 2 minus n plus 1 minus 2. So I'm writing directly 2 raise n plus 1 minus 2. Okay. So this I hope you have a bit idea. So I'm just writing it directly. Otherwise you have to go back to geometric progression and then understand this. Okay, so when you have to do sigma 2, that means 2 sigma n, sigma 1 and sigma 1 is n. So that is 2n. So this n won't change, n square won't change, n won't change, n plus 1 by 2 won't change, 2 raise n plus 1 won't change because there is no r there and no constant there. Okay, so sigma n, because the addition is from r equals 1 to n. Since r is not there, it is a constant term, so it will remain as n. Okay. So we are only interested in sigma 1, sigma r, sigma 2 raise r and sigma 2. So these 4 terms, the addition I have already written. Sigma 1 was n, sigma r is n plus 1 by 2, sigma raise 2 raise r is 2 raise n plus 1 minus 2. The final step is what? Let me just clean it. See, this is the final one. Now we'll do row 1 minus row 2. Or you see, row 1 minus row 3 is a good idea. Why? Because we have row 1 as n, we have n. In row 3 also we have n. So if we subtract this, row 1 minus row 3, so n minus n is going to be 0. n plus 1 by 2 and n plus 1 by 2, that is going to be 0. And 2 raise n plus 1 minus 2 minus 2 raise n plus 1 will come. So minus 2 raise n plus 1, this gets cancelled. It will be negative 2 here. This is negative 2. Okay. Now 2n, n square. Let us keep others like that. Just open it using the first row. So 0, 0, I'm not writing it. Just minus 2. What will come here is this 2n, n plus 1 by 2. Okay. So let us take n from n outside from first row, second row, or first column, second column. So n square will come out. So what will remain? 2, 1, 1 and plus 1 by 2. So 2 into n plus 1 by 2 minus 1. 2 gets cancelled, n plus 1 minus 1, 1 gets cancelled, you get n. Then you have minus 2n square outside. So it will be minus 2n cube. So as I said, It will be minus 2n cube. The answer is minus 2n cube. This is how it comes. There are various concepts being used here. If a is greater than 0, this is very important because this is going to be used in the answer. Discriminant of ax square plus 2bx plus c is negative. Discriminant is b square minus 4ac. Okay, this is negative. Then this determinant will be what? So what we'll do here is, remember b square minus 4ac is less than 0, and since b is 2b here, so it will be 4b square minus 4ac. That is b square minus ac. B square minus ac is less than 0. Since a is greater than 0 already, so b square minus 4ac will always be 0, less than 0. Now what we'll do here is, see, a is there, ab and bc, and in the third row we have ax plus b. So what we'll do here is, we'll multiply the first row with x, second row with nothing, and then we subtract. So a into first row with x, second row with nothing. So we have to do R3 minus x into R1 minus R2, right? So this second one also like this only, bx plus c minus bx minus c. And since we have a 0 here, everything in the last element, two elements of the last column will come as negative, because it will be 0 minus ax plus b minus bx plus c. So I'm just writing like this, minus ax plus b plus bx plus c. Let us open it using the third row. When we open it using the third row, what do you get? The first two elements I am not going to write because they will eventually be 0. So third we are going to write. It will be minus ax plus b plus bx plus c. So it will be simply ax plus bx plus b plus c you can write. So ax plus bx plus b plus c, and then we have ac minus b square. Okay, I just told you ac, b square minus ac is always less than 0. Okay, and since b square minus ac, and we have already seen that b square minus ac is less than 0, and since a is greater than 0, and we have a negative sign also. So whatever happens, the result will always be negative. I hope you got the idea. This AC minus B square was there. We took the negative inside. B square minus 4 is AC. B square minus AC is always less than 0, as we discussed earlier, since A is greater than 0. So this whole concept, this whole expression will always be less than 0. Since ax square plus this ax square plus 2bx plus c will always be positive. B square minus AC always be negative. So the whole result will always be negative. I hope you got the idea. You need to just understand those concept of the linear equation and the quadratic equation. Quadratic equation, we know how to do that. B square minus 4ac is less than 0. That is why we are saying it to be 0, because ax square plus 2bx plus c is discriminant of this is negative. That is why we took it. And ax square plus 2bx plus c is not going to be 0. That is why it is 0. Negative, sorry. The value of this. So this kind of question we have already done. So what we'll do here is, from the first row or the column, it is up to you. I am taking 5 square from the first row, 5 cube from the second row, and 5 raised 4 from the third row. So what all is remaining? This is 1, and this is going to be 5, this is going to be 5 square. So 1, 5 and 5 square. From second row we are taking 5 raised 3. So 1, 5 and 5 square will come. Then the third row we are taking again 5 to the power 4 common. So you get 1, 5 and 5 raised 2. Now you see, for a determinant to be 0, we need 2 rows or 2 columns to be same. Here we have 3 rows as same. So it is obviously going to be 0. Determinant, but you know the property, determinant is going to be 0. Now in this question, each and every element, you can say. How to write that? Main is this. Log 3 base 3 is 5 and 2. So 5 and 2 is 2 raised 9. So you can write it as log base 3. This is 2 raised 9. So 9 goes in front. Log base 3 2. This is the first one. All of them you have to do. I'll show you one more of it. Log 4 3. Now log 4 3, 4 can be written as 2 square. This is 2 square 3. Now 2 square when it come outside it will be half. So log 2 3. So first one I showed you the log 3 8 now. Second also we saw. Log 3 8 is log 3 8 can be written as 2 cube. So 3 comes in front, 3 log base 3 2. I hope you how did it come? You got the idea? Now log base 4 3. Log this 4 can be written as 2 square, 3 raised 9 can be written as 3 square. So half will come from 2 square, 2 will come from 3 square. So half and 2 this gets cancelled, log base 2 3. Now all of this log 2 3, log 8 3. So this also you can write. Let me show you here also log 8 3. 8 can be written as log 2 cube 3. So 1 by 3 will come outside. 1 by 3 log base 2 3. And then we have log base 3 4. So log base 3 4. This 4 can be written as 2 square. This comes in front. 2 log 3 2. Okay. So all of this we are going to take one by one. Log 3 4 is log base 3 2 square. 2 will come outside. It will be log 3 2. So each and every element you have to use the property of log and write. Now I'm just clearing it now. Let us take things common. From this log 3 2, log base 3 2, whenever I'm saying log 3 2, base is there, log 3 2. And log 2 3 you can take outside. But you know log 3 2 and log 2 3, they are inversion of one another. So you can just cancel it out. Right? If you take a common base, it will log 2 by log 3, log 3 by log 2, it can be cancelled. What is remaining? 9 3 minus 9 3 half and 1. This is what is remaining. From the second matrix or determinant, first let us do this one. 9 minus 3 by 2, it is going to be 9 to 18 minus 3 by 2, it is 15 by 2. Now here, you can take log 3 2 and log 2 3 common, and this also says log 3 by log 2, log 2 by log 3. Log, if you take a common base, it can get cancelled. So it is going to get cancelled. 1 by 3, 2 will come. So 2 minus 2 by 3. So it is going to be 6 minus 2 by 3. So it is 4 by 3. So 15 by 2, the log all got cancelled. Log 3 2, log 2 3. In both the cases, it gets cancelled. Here also. So you can just cancel those in front of these numerals. And finally, what do you get? 15 by 2 and 4 by 3. So 15 by 2 and 4 by 3, let us write it. 15 by 2, 4 by 3. And 2 gets 2. 15, 2 is 30. 30 by 3 is 10. So answer is 10 here. If ABC are in AP, what does it mean? AP means in arithmetic progression. So this determinant ABC, if they are in AP, if ABC are in AP, that means twice of B is equal to A plus C. Essentially it is B minus A equals C minus B. So this becomes 2B equals A plus C. So we'll apply the property such that you get somewhere 2B equals A plus C, so that you can get a 0 or the computation can be made easy. Okay, so we have this x plus 2a. How do we do, say, some r1 plus r plus r1 plus r3, and then we subtract it with twice of r2? Just see here. See, and that will give us the solution. This is row 1, this is row 2, and this is row 3. So let us add row 1 and row 3. When we add this and then subtract it by twice of the row 2. So x plus 2 and x plus 4 will be what? Just let us see one of these. X plus 2 and x plus 4 is going to be 2x plus 6. Now you have to subtract x plus 3, which we made as twice. So 2x plus 3 is 2x plus 6 only. So 2x plus 6 minus 2x minus 6 is going to be 0. So this will be for all of this. So what we'll do is, let us take the third one also, x plus 2a plus x plus 2c, and then subtract twice of x plus 2b. So x plus, this is 2x, this is 2a plus 2c, this will be minus 2x and minus 2 to the 4b. So minus 2x minus 4b it will be. Okay, what do we get here? We get 2x gets cancelled. Twice you can take common, and this will be a plus c minus 2b. And we know that 2b equals a plus c. So a plus c minus a plus c is going to be 0. Right? So what we are doing is, we are changing R1 to R1 plus R3 and then subtracting twice of R2. Twice of R2. Please remember, it's twice of R2, not R2. So you got 0. And what about a plus c minus 2b? It's also 0. So you get 3 zeros in the first row. And when you get 3 zeros in the first row, that means it is going to be 0. If a plus b plus c equals pi, then the value of, so a plus b plus c pi, let us write this a plus b plus c and a plus c and a plus b and a plus c, b plus c in terms of such certain sine or cos value, so that we get a particular value. For example, this a plus b plus c is pi. A plus c is what? It's pi minus b. Now a plus b is what? Pi minus c. And b plus c is what? It's pi minus a. A plus b plus c. Now c plus a is remaining. So a plus c is pi minus b. So we got all of this. Now a plus b plus c, we will put pi. In place of a plus c, we are going to put pi minus b. Similarly, at the place of a plus b, we will replace it by pi minus c. And b plus c, we are going to replace it by pi minus a. Now you see, says this is sine. Sine 180 is what? It's 0. Sine 180 is 0. Sine 180 minus theta. Sine 180 minus theta is what? Sine pi minus b will be what? It will be sine b. Sine 180 minus theta. So we can write this as sine pi. This sine minus pi minus b, will just write sine b. And this is sine b. Cos c will keep it like that. What about cos pi minus c? It's minus cos c. And then we have this tan pi minus a is minus tan a, minus tan theta. So all these values have come, and 0 is in the diagonal. All the diagonal elements are 0. Right? Now let us take the transpose of this. When we take the transpose of this, that is the first row I am taking as the transpose, 0 sine b cos c. This second row I am making it as a column. It will be minus sine b, 0 and tan a. Then this row as the column, so it will be minus cos c, minus tan a and 0. Now this transpose we have taken, and if we take negative common from here, negative out from here, what do you get? 0 sine b cos c. It will be sine b 0 minus tan a, and see, because 0 0 0 is in the diagonal, when you take the transpose and take the negative outside, the same matrix is going to come again. Okay, 0 sine b cos c minus sine b 0 tan a minus cos c minus tan a, 0 will come. So this was a. So when we took the transpose, a transpose is equal to a, not minus a, because it is skew symmetric. So we have a 3 by 3 matrix, and since this matrix is skew symmetric and order is odd, so the determinant has to be 0. This we have already seen. The number of distinct real roots of this is equal to 0 lies in the interval minus pi by 4 less than equal to x less than equal to pi by 4. So number of distinct real roots. So minus pi by 4 less than equal to x pi by 4. So there are multiple ways to do it. The way to do it, because the correct option is second here, which is B. Okay. This cosec C and sec C, we know that this can be written as 1 by sine, 1 by cos. This is one of the way. We know that cosec square and cot square and sec square and cot square are related. So what I am suggesting is this kind of question. How to solve it? This only comes with the experience. Once you do this type of question multiple of times, we know what we have to do, because as I said, we can use it. We can apply the 1 by cos. We can apply some other tactics also. Let me show you here only, because there are so many sine and cos and cosec and tan here. Okay, cosec x. Let us take common here. There are so many secs here. So if I take sec x from its outside, then you'll get plenty of 1. But are you able to solve using that thing? That is, if you take sec x, will you be able to solve it? I think we have to take some other measure. The measure is, when we take cosec x common, there will be some way we can reach at the solution. Because ultimately we need certain values, certain terms that can be put as 0, because they are asking about real roots. So we have to make an equation. So cosec x, cosec x, cosec x. As I said, taking sec x may solve this question, because there are multiple ways to solve a question. So if I take sec x say common, what it will be? Cosec x by sec x 1 1. So we get, if you take sec x common, 1 1 1 will be there. Let me show you more also. So 1 here also sec, you can take sec square and it can be sec cube also. But this sec cube is going to give you the solution. Let us take, as I just suggested, let us take cosec x. If we take sec, it will be cosec by sec. Cosec is 1 by sine, and of course sec is 1 by cos. So it goes cos by sine, that is going to be cot. Are you comfortable dealing with cot? I am comfortable dealing with tan, because maybe I remember the tan equations now, or identities. I don't remember the sec. If you remember sec, then you can take sec outside. Right? When we take cosec x outside, you will have tan inside, and I am quite comfortable to actually work with tan. So cosec x I am taking common. Cosec x, when we take common from the rows, so wherever you have cosec x, put 1, and wherever sec x is there, you put sec x by cosec x, because you are taking actually cosec x common. So sec x by cosec x, as I just told you, it will be tan. So this has come. Now let us apply rho 1 minus rho 2. We'll change rho 1 to rho 1 minus rho 2, and we'll change rho 2 to rho 2 minus rho 3. And this we are just doing to get enough zeros so that we are able to open it. And when we open it, maximum the 0, easier it to be solved. So 1 minus tan x minus 1 and 0. Now this also comes with R2 minus R3. So you take 1 minus tan x, you see 1 minus tan x is there in the first row. 1 minus tan x is in the second row. So 1 minus tan x we can take common. So when we take 1 minus tan x common, what we get? And if you take 1 minus tan x from tan x minus 1, you'll get minus 1 as a remnant. So I am taking 1 minus tan x from first row, 1 minus tan x from the second row. When I take 1 minus tan x from both the rows, we are remaining with 1 minus 1 0 0 1 minus 1, and the last row remains the same, like tan x 1. So this is you can open it using first row or first column. Let us open using the first column, say. So the cofactor will come when you take 1 minus 1 tan x, 1 will come. When you take tan x, it will be minus 1 0 1 minus 1. So what do you get here? When you take this 1, this is 1 minus plus, it is tan x. 1 plus tan x will come. And what do you get here? Tan x, and minus 1 is 1, 1 minus 0 is 0. So it will be 1 into tan x. So 1 plus tan x plus tan x is simply 1 plus 2 tan x. When we have 1 plus 2 tan x, we already had 1 minus tan x all square outside. And cosec x whole cube, when we get taken cosec x from all the three, the rows. So when determinant is 0, it will be cosec x equals 0. It will be 1 minus tan x equals 0 or 1 plus 2 tan x equals 0. So cosec x 0 or tan x equals 1 or 1 minus tan x equals 0 means tan x equals 1 or 1 plus 2 tan x equals 0, that is tan x will be equal to minus 1 by 2. So cosec x 0, cosec is 1 by sin x. So 1 by sin x, so that is sin x equals infinity. So that we cannot take. Tan x equals 1, we can take. Tan x equals minus half, we can take. So the number of distinct real roots between minus pi by 4 and pi by 4. So what you need to know all the values also, sine and cos and everything. Because I know it, so I can tell you that cosec x equals 0 is 1 by sin x equals 0, sin x equals infinity, that we cannot take. But tan x equals 1 and tan x equals minus 1 by 2, that comes inside minus pi by 4 and pi by 4. You can just say x equals tan inverse x, tan inverse 1, you know the value. You get tan x or x equals tan inverse minus 1 by 2, that is in between this minus pi by 4 and pi by 4. So these are the two real roots. Tan x equals 1 and tan x equals minus half. You will not take cosec x equals 1. You can solve this question using sec x also if you take sec outside. That is also possible. So 1 and minus 1 by 2 is the answer here. Okay. So this is how we do it. This is the correct option is 2. Now let us proceed to the next question now. Let A equals this one, where theta is between 0 and 2 pi. So we have determinant A equals 0, determinant A belongs to 2 to infinity, determinant A belongs to 2 to 4, and determinant A belongs to 2 and 4. 2 and 4 sometimes it is included, sometimes it is not included, which is the answer. Okay. Now, if you are not able to go ahead, you don't know how to proceed forward, the best way is to just open it, and you will the codes of solution will follow, right? So let us do this. What we'll do, just to get some zeros, we see that we have the column 1 is there, column 3 is there. So if you add minus sin theta by sin theta, you'll get a 0. You get 1 with minus 1, you get a 0. And you get 1 plus 1, you get 2. So column 3 we are changing, column 3 plus column 1. So these two values of the third column is going to be 0. Only 2 will remain. So we'll open it using the third column. Twice of cofactor is what? No, cofactor will be minus sin theta 1 minus 1 is minus sin theta. So you get 2 sin square theta plus 1. This is what we got. Now let us come to the actual trigonometric aspect, because theta is between 0 and 2 pi. Now sin theta is between minus 1 and plus 1. Sin theta is always between minus 1 plus 1. So because we need a twice of sin square theta plus 1, the value, so we'll just square it, sin square theta. When you square it, it will be from 0 to 1. Because the range, when we do the square, it will be negative, it will never be negative value. So minus 1 to 0 will not come. It will start from 0, it will go up to 1. So sin square theta is between 0 and 1. Right. So now sin square theta plus 1 is there. So let us add 1 on both the sides. So you get 0. This is 1. 1 is less than equal to sin square theta plus 1. And this is less than equal to 2. Now subtract 1 from, no, you have to do 1 and 2. So you have to multiply by 2. So let us multiply by 2 twice of 2 sin square theta plus 1. This is equal to 4. So this is between 2 and 4. And 2 and 4 are inclusive. So what will be the answer? The square bracket you are going to take. Round bracket when 2 and 4 are not inclusive. So 2 and 4 are inclusive. That is why we are not going to take the C option. We are going to take the D option. This is your answer. Determinant of A is belonging to 2 and 4. So round bracket, square bracket, that also, see, they are same answers, but a quite difference. Now if 2x, 5x, 8x equals 6 minus 2, 7, 3, just take the determinant. 2x square minus 5 is 40, 6 is 18, minus 7 is 14, plus 14. 2x square equals, this is 18 and 14 is 32, 32 plus 40 is 72. So 72 it is, 2x square. Now let us divide both sides by 2. You get x square equals 36. So x is equal to plus minus 6 here. So you see the answer third is highlighted. So in order to solve this, just take the determinant, equate it, and the correct option will be C here, right? So here we have fx equals 0x minus a, x minus b, x plus a is 0x minus c, x plus b, x plus c is equals 0. So in place of x you can place a, b, 0, 1. So you have to do it for all of it. Just replace x by first 0, a, b, 0 and 1. So I am putting 0 right now. When you put f0, you will get 0 minus a minus b, a 0 minus c, and b, c, 0. Okay. So let me tell you one more thing. Let us complete this first. So f0 is this is coming. Now this is a 3 by 3 matrix, and I'll apply a different tactic because by experience and the number of questions we have already seen, this is A. Let us take A transpose. What do you get? You get 0. I'm making the row as column. This is 0 minus A minus B. I'm making it as a column. It will be 0 minus A minus B. This is the second row. I'm making it as a column. I'm transposing it. So row and column conversion. Or you can say changing. BC is 0. Okay, this is nothing but if you take minus common. When you take minus common, this will come as the first matrix A only. 0 minus A minus B, A 0 minus C, and BC 0. This is nothing but A only. So when we took the A transpose, the A has come back with a negative sign. That means this matrix is a skew symmetric matrix. And with the skew symmetric matrix, we have this is as the 3 by 3 matrix. When the order is 3, it's going to be odd. So A transpose is negative A. That means it will be a 0 matrix because of the odd order. So there are other methods also. As I said, you just have to put A, B, 0, 1 in all of it, and you can open it also. If you put A, B and solve it, you put 0, you solve it, we are going to go get essentially 0. But when we have the properties, we can just easily apply the properties and solve it in no time. If you open it, that will take time because putting A as 0 and all this will take some time. This question. The value of the determinant. So here we see a determinant where we have certain columns that can be added and we can get 1, and then we can just do some row subtraction, column subtraction, and we'll get some zeros. So if you see this B plus C, C plus A plus B, this is the second column. If you add this with the third column, you are going to get ABC, 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 everywhere you'll get, right? Now, when you add this, you can take these common. So A plus B plus C, you can take common. So let me just show you here. So there are multiple ways, as I said, multiple ways to do it. This is column 1, column 2, column 3. So what we are doing is column 2 and column 3 we are adding. We are changing column 2 to column 2 plus column 3. So the middle column will be A plus B plus C. And that A plus B plus C I am taking common. I am taking outside. So only 1, 1, 1 will remain in the second column. So column 2 is changed to column 2 plus column 3. And when we add this, we take A plus B plus C outside. 1, 1, 1. Then we have this A minus B, B minus C, C minus A. Column 1 will take, if we change column 1 to column 1 minus column 2, what are you going to get? A minus B minus A. So A minus B minus A gets cancelled, you will get minus B. Write minus B here. B minus C minus B. So you get B minus C. C minus A minus C. So you get minus a here. Here you have ABC already. So you can take negative 1 outside. And one more thing we can do. We can exchange the rows or columns so that rather column will be beneficial. So row 1, row 2, row 3, and we'll get rid of that minus 1 also. So I'm exchanging it. I'm exchanging column 1 and column 2. So column 1, we are exchanging it with column 2 so that we get 1, 1, 1 here, BCA here, ABC here. Okay. Because we just don't want minus 1 here. And then A plus B plus C is already we have taken out. Now you can take 2 rows at a time and subtract them so that you get zeros. So row 2 minus row 1 will do, row 3 minus row 1 will do. Always in this type of cases, we always do row 1 minus row 2 minus row 1 and row 3 minus row 1. So you get 0, C minus B, B minus A here. I'm showing it here only. Row 3 minus row 1 will be 1 minus 1 is 0. A minus B it will be, C minus A it will be. So we'll open it using the first column. So first column will be 0, 0. I'm not writing, only 1, C minus B, C minus A here, A minus B, B minus A. So A plus B plus C is already outside. So we get C minus B into C minus A minus A minus B into B minus A. Now you have to do all the multiplication. So A plus B plus C is already there. You have to do proper multiplication and then you have to multiply A plus B plus C also. Means, I'm saying A plus B plus C was already outside. We have multiplied C minus B, C minus A. Then we added the multiplication with the result of B minus A and A minus B. Then whatever is coming, we have to multiply again. So when we multiply again, there will be various cancellation. So you'll get only 3 ABC, 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 ABC. This is 3 ABC and A cube, B cube and C cube only will remain. Others all will be 0. Because let's see this BC square. So we have a BC square plus and BC square negative. So you can just cancel it out. Okay. If X, Y, Z are different from 0 and this equals 0, then the value of X inverse, Y inverse, Z inverse is. So what will be the answer here? The answer is 4th. How it will come? How we have actually achieved this? So I'm just opening, I'm not making it 0. I will encourage you to do row 2 minus row 3, then row 1 minus row 3. Change row 2 to row 2 minus row 3 and row 1 to row 1 minus row 3. But I am not doing this. I'm just opening it because the way is same. Whatever way you apply, the answer is going to come same. There is no other answer which can be achieved using taking some other steps. So I am not making it 0. I'm just doing it all together like this. 1 plus x, then minus 1. I'm opening it using the first row. Then we have 1 plus z. Then we have plus 1. So 1 plus y and 1. Okay. So 1 plus x, this has come. I'm just verifying it. And from 1, this has come. Okay. So 1 plus x. And let us solve it. 1 plus, I'm solving the internal one. 1 plus y into 1 plus z minus 1. 1 plus x is already outside. Then minus 1. What do you get? Z plus 1 minus 1. So here you get 1 into 1 minus y. Okay. So this will, 1 will get cancelled. It will be minus z. 1 get cancelled. You get minus y. So you have minus y minus z. Now let us multiply this one. I just multiply this one. So 1 plus y and 1 plus z will multiply. And then we already have a subtraction 1. So it will be 1 plus z plus yz minus 1. So minus 1 gets cancelled. Now z plus yz and we will multiply it with 1 plus x. You get z plus yz plus xz or zx plus xy plus xyz. So it is not yz, it is xy. There is a slight correction here. So z and y gets cancelled. You have yz plus xy plus xyz. Now let us divide both sides by, or one right hand side is 0 already, so it will be divided by xyz and xyz. So this will be 1 by x, this will be 1 by y, and as I said, this is going to be, this is not yz, this is because yz, zx we have already taken, so it will be z, because we need x in the z in the denominator. So we have xy here. So I'll just change it. As I said, there is a slight correction here. So the multiplication which we did, there is a multiplication of 1, that was z plus y plus yz. Then we multiplied x with z plus y plus yz. So we had zx, xy and xyz. So finally, I hope you got the idea, right? So finally, whatever it comes, you have to divide it by x plus y plus z. Then you have 1 by x plus 1 by y plus 1 by z. And that is essentially equal to x inverse, y inverse, z inverse equals -1. Right? So this is how the right hand side has come as -1. That is why I am saying it's -1. The fourth option is the correct option. So this is the solution. Whichever way you do, the answer will come as -1 only. The next one. Here we have to see certain factors, and we'll take certain factors common. So this we have b square minus ac, ab minus a square. So we can take b common from here in b square minus ab, and ab minus a square. Let us do the first one first. B, I'm taking b minus a, b minus c here, and we are taking c here. So b minus a it will be. Now next one, ab minus a square. Let us take a common. B minus a minus b it is. Then we take b common from here, b minus a. Here we take c common, you get b minus a. Here you have c minus a. Here you take a common, you get b minus a. So from here, first column I am taking b minus a common. From the third column also I am taking b minus a common. So when we take b minus a common, you will get b minus a whole square. Then you have b, a, c here, b minus c, a minus b, and c minus a here, and c, b, a here. Right? Okay. You can do one more thing here. B and c is already there. So let us subtract the column 2 and column 3 from column 1. So I'll just show you. B minus c, that is b plus c minus c. So b gets cancelled, c gets cancelled. So you have column 1 we are changing to column 1 minus column 2 minus column 3. And this is 0. Then we have same thing here. A minus a plus b minus b, again 0. C minus a minus a. This all gets cancelled, 0. So other things I am writing, but I can see that one of the column is 0. When one of the column is 0 or one of the row is 0, the determinant will be 0. If xy belongs to R, then the determinant. So xy are real. Okay, let us see here. Now you have to see that cos x plus y is what? You need to know what cos x plus y when we open it. Because you know whenever we read trigonometric identities, those formula will be used everywhere. So if you are not able to do it or say prove it properly, just mug it up, because this will be used. So if you multiply the first row with cos y, second row with sin y, what do we get? So row 3 we are changing to row 3 minus cos y into row 1 and minus sin y into row 2. You'll see just now what will happen. We'll get two zeros here. How? First I am showing you cos x plus y minus cos y. Row 1 we have cos x, then we have sin x sin y. So sin x sin y, and if you take minus common, this is cos x plus y, and when we take minus common, you get what? Cos x cos y minus sin x sin y, and which is nothing but cos x plus y. So cos a cos b minus sin a sin b is cos a plus b. It is cos x plus y. You can just cancel it. It is 0. Similarly, minus sin x plus y minus sin x into cos y, minus minus will be plus, and then minus cos x sin y, that will again give you a 0. And the third column, so it will be cos y with first one, second y sin y, so you get 0 minus cos y minus sin y. So that will be sin y minus cos y. Okay. Now we'll use the third row to open it. Third row. So sin y minus cos y. Here you get cos x minus sin x, cos x. Cos x, sin x minus sin x, cos x. Right. So you get cos square x, and minus minus will become plus, cos square x plus sin square x. So this is going to be 1. Sin square x, cos square x 1. So you get sin y minus cos y. Okay, we have already seen, because we need to know what is the range, you can say, or the boundary. So multiply it by root 2, and 1 by root 2, 1 by root 2 will be here. So 1 by root 2 you can write as cos 45 degree, that is pi by 4. Here you can write 1 by root 2 as sin pi by 4. So root 2 is outside, you get cos pi by 4 sin y minus sin pi by 4 cos y. Because cos 45 degree, sin 45 degree, they both are 1 by root 2. So root 2. So you get cos a sin b minus sin a cos b, that is sin a minus b. So sin y minus pi by 4. Whatever is there, sin theta can be anything, but sin will always be between -1 and +1. Always. So -1, +1, root 2, because root 2 is there, so multiply root 2. Root 2, you get sin theta root 2, and this is going to be root 2. So you have minus root 2 to root 2, so this is the first one is the option. Theta is real here. The maximum value of this determinant will be, so whenever we have one row or one column is 1, 1, 1, there is a simple way to do it. Row 2 you will change to row 2 minus row 1, and row 3 you will change to row 3 minus row 1. That is the only thing which we will do, unless until you have something to take common. So R2 minus R1 you will change R2 like that, and R3 will change as R3 minus R1. So 1 plus cos theta minus 1 will be cos theta. 1 minus 1 will be 0. 1 minus 1 is 0. Now coming to second row. 1 minus 1 is 0. 1 plus sin theta minus 1 is sin theta. And 1 minus 1 is 0. 1, 1, 1 will be here. And you can open it using any row or any column. So I am using the third row. So cos theta, it will be 1, 0, 1 sin theta. 1, 0, 1 sin theta. No, 1 sin theta or 0, 1, 0. So 1 into 0 is 0, minus sin theta, cos theta is outside. So minus sin theta, cos theta it will be. So multiply with 2, divide by 2, you get sin 2 theta. Because 2 sin theta cos theta is sin 2 theta. Sin 2 theta by 2. So you have minus half sin 2 theta. I told you sin theta is always between minus 1 and plus 1. Any value. So it will be minus 1 and 1, 1. Since we have minus half, when we multiply minus negative, the sign will change. Inequality sign will change. So I am multiplying both sides by minus half. All of the element with minus half, the sign will change. It is half greater than equal to sin theta. And then we have greater than equal to negative half. So what is the maximum value? It is going to be half. 1 by 2 is the answer. This is the answer. The value of the determinant. Okay. The answer is second, but how does it come? I can see that we can take certain thing common. How? Either you subtract any row or column, you get some zeros, or you can get 1 1 1 in any row or column, you will get definitely 2 zeros. So what I am trying to do here is I am doing something different here. I am going to add 3 rows, all of the 3 rows. So because it is going to come as 3x plus 3y. So R1 I am going to change as R1 plus R2 plus R3. So you get 3x plus 3y. X plus x is 3x plus 2y and y is 3y. Similarly here also 3x plus 3y. So you get x plus 2y here, x plus y, x plus 2y, x plus y and x. Okay. Now you can take 3x plus 3y common. And as I told you, that when we take common, definitely we are going to get 2 zeros. So I am taking 3x plus 3y or 3 into x plus y common. Now, simply column 2 minus column 1 and column 3 minus column 1. We don't do column 2 minus column 1 and we don't do this column 3 minus column 2. No. Column 2 minus column 1 and column 3 minus column 1. So column 1 will remain like that. 1 plus x plus 2y, x plus y. Now 1 minus 1 is 0. X minus x plus 2y will be x minus x plus 2y. X gets cancelled. You get minus 2y here. Then x plus 2y minus x minus y. So you get 2y minus y is y. Now call column 3 minus column 1 I am doing. So 1 minus 1 is 0. And you can do column 2 minus column 3. But just I am suggesting the pattern you should follow. Now x plus y minus x minus 2y. So you get minus y here. And then x minus y. You get a minus y here. So we'll open it using the first row. Since we have 2 zeros here. Remember we have 3 times x plus y already outside. So I am opening it using the first row here. So 1 minus 2y, y minus y, minus y. Then you can take y common from here. From first row, first column and second column. So minus y I am taking from the second column, y from the first column. So what do you get? Minus 2, 1 and 1, 1. So minus 2 into 1 minus and minus 1. So minus 3 it is. So minus 3 minus y square was already there. 3 times x plus y was already there. So minus minus gets cancelled. 3 is 9. So you get 9y square x plus y. And that is going to be your answer. Okay. See, there are different ways to do it. But the answer will come same. Answer will not change. This is one of the way. I told you another way. You can also devise your own way. So there is no hard and fast rule to do every question by one way. Now let fx is this determinant or matrix, and limit x tends to 0, fx by x square we have to find out. Fx, that means we have to apply limit x tends to 0, then divide this fx by x square. Then when we apply the limit, what will be the value? So we'll try to make as easy as possible, that is maximum zeros we can get. And since we see that the second column has x, 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 so either you take x common and then you can do 2 minus 1 and 3 minus 1, that is row, of course. And doing row 2 minus row 3 will give you x minus x and 2x minus x. So that will be quite easier. And when we do row 3 minus row 1, what do you get? You get x minus x and x minus 1. So let us do like that, or any other row or column combination that you can do so that you get easier determinant to be computed. So I am doing R2 minus R3, row 2 minus row 3. So what do you get? Row 2 minus row 3, it will be 2 sin x minus sin x sin x, x minus x 0, 2x minus x is x. Next one is R3 minus R1, we are changing. So sin x minus cos x, x minus x is 0, x minus 1 it will be. Okay. Now this column, second column, we are going to use to open it. So this will be negative x, please remember. Negative x, minus plus minus it will go, but I am not writing the other thing just because there are 2 zeros here. So I am not writing the other thing. So what do we get? You have because it is a1, 2, and minus 1 to the power 1 plus 2 is minus 1 to the power 3, that is going to be negative. So what do you get? Sin x, sin minus cos x, x minus 1. So now you get sin x minus 1 minus x sin minus cos, and you have already minus x outside. As I suggested, you could have taken this x already in the first go outside, but let it be like that. Let us multiply here. I am just taking minus inside, so changing the positions, x sin minus cos minus sin x minus 1. Now open it. X sin x minus x cos x minus sin x, x sin x plus s. So sin x, x will get cancelled. You get sin x minus x cos x. Let us write it properly now. Sin x minus x cos x. But please remember, negative x, we have already used the negative. Now x is already there. So now multiply this x inside, and then we'll take the limit x tends to 0 after dividing it by x square. So now multiply x. So fx by x square we have to do. So we have to divide it by x square first. So x square, x square. So this becomes sin x by x. Limit x tends to 0 here we will apply. X square gets cancelled. Cos x, limit x tends to 0 will apply. So this is going to be 1. Sin x by x, limit x tends to 0 is always 1. Minus cos x again 0, this is going to be 1. 1 minus 1 is 0. There are two values of a which makes the determinant that dash determinant thus equals to 86. The sum of these two values is, you just have to open the determinant and just equate it to 86 and find out the value of a. Either you can make it easier if it is possible. I don't think doing it, I think doing it will be just extension of time. So let us open this. 1 minus 2, 1 minus 2 minus 2. I'm using the first column, that is why we are getting 0. So I'm not using 0. So 1 minus 2, when we take 1 it will be a4 minus 1 2a. When we take 2 it will be minus 2 4 5 2a. It will be 2a square minus plus 4 minus 2, you get minus, so you get minus 4a minus 5 4s are 20. So since minus is already there, so I take minus outside and make it plus 4a plus 20, and this is going to be equal to 86. 2a square plus 4 is 8a plus 4d equals 86. Okay, 2a square plus 8a, this is 44 and this is 86. So it will be 86 minus 44, you get 42. So minus 42 equals 0. You can divide 2 or take a2 common. A square plus 4a minus 21 equals 0. 7 3s are 21, so we'll use 7 and 3. A square plus 7a minus 3a minus 21 equals 0. A you can take common, a plus 7 minus 3, a plus 7 equals 0. So a minus 3, a plus 7, a minus 3 and a plus 7. This is going to be your result. A equals 3 and a equals minus 7. Okay, so what is the sum? 3 minus 7, of course, minus 4 is you are going to get. If this equals 16, what is the value of this whole matrix and the determinant of this matrix? Normally what we understand when we learn this for the first time, we understand that we are going to open it like this. P, Q, R, A, B, C and A, B, C in the first go. That is the first part. And then we add it with the second part. That is X, Y, Z, X, Y, Z again. That is X, Y, Z. Sometimes people say Z, sometimes say Z. Then P, Q, R. So the two columns are same in both the matrix. We say 0, 0, 0 plus 0 is 0. But that is wrong comprehension. So better is to understand what actually happens. First, you will take PQR. A plus X will remain like that, A plus P will remain like that, B plus Y will remain like that, C plus Z, B plus Q, C plus R, all will remain like that. And only this first column will be X, Y, Z. Next will remain as it is. You cannot open the way I told you the first time. This is the actual way it should be opened. This is the actual way. Now, I hope you got the idea. Now this is not over. Now when we open this PQR, when we open this first, it will be a PQR, ABC, and A plus B, B plus Q, C plus R will remain like that, right? Now second time when we open it, that is the second part of this one, it will be PQR. Now this will be XYZ, and A plus B, B plus Q, C plus R. Now let me tell you here about. Suppose you are dividing it into two matrix of addition. It will be XYZ in the first column, ABC will be the second column, first column same ABC, and the third will A plus B, B plus Q, C plus R. And then we have XYZ will remain like that. Here it will you will get XYZ in the second column, and A plus B, B plus B, C plus R. So you need to open it all the way, and that is how this whole opening will take place. I hope you got the idea. This is how we get it open. Now you see this first column, second column equal, it becomes 0. 2 rows, 2 column equals, that means 0. This also becomes 0 because 2 columns are equal. Here no. Here we have every row column different, so we cannot make it 0. Here we have PQR, 2 columns 0, so it is 0. Here we have 2 columns 0, so make it 0. And then we have, no, this is not done. XYZ, yes, it is going to be 0. XYZ, this is also going to be 0. Because 2 rows, 2 columns is 0. Now these two are, this will make twice of this matrix. Why? They are not equal right now, but we can make it like that. If we exchange the columns 2 times, you are going to get the same matrix as the first one which I am pointing. I'll just make it this column 2, column first, column 1 and column 2 we are going to exchange. Negative will come outside, of course. So PQR, ABC, and this XYZ. So we have exchanged the column 2 and column 3. Then column 1 and column 2 we are exchanging. First we did column 2, column 3. Now we are exchanging column 1 and column 2. So this will be PQR, XYZ, ABC. Minus, previously minus has come, then next exchange minus has come, minus become plus. It will be twice of this matrix, which is 16. Twice of 16 is 32. Now in this question, first, what is NCR? What does it mean? NCR, this has come from binomial. So it will be factorial R, factorial R, factorial N, factorial R, factorial N minus R. So NC1, and then what do you get NC1? You get a factorial N, factorial 1, and factorial N minus 1. So N you can take out, it will be N minus N factorial N minus 1. 1 is already there, factorial 1 is 1, so we can leave it. This gets cancelled, you get N. So you got the idea, N plus 1, how it becomes N. Now N plus 2 C1, N plus 4 C1, and see all these you know how to do it, but I'll let us do one more of it so that you understand better and complete NCR how it is done. I'm taking N plus 4 C2. This is factorial N plus 4 divided by factorial 2 divided by N plus 4 minus 2. So this is factorial N plus 4, this is 2, and this is N plus 4 minus 2, N plus 2 it is. So N plus 4 you can take N plus 4, then N plus 3, and then factorial N plus 2. Division 2 factorial N plus 2, this gets cancelled. You get N plus 4, N plus 3 by 2. I hope you got the idea how you are going to do for each and every element of the second and third row. So column 1, column 2, column 3, we'll try to make it easier. You always know when we have 1, 1, 1 in any row or column, we just subtract them. So column 2 minus column 1 will do change to C2, C3 will change to C3 minus C1. So 1 minus 1 is, I'll show it here only. 1 minus 1 is 0, N plus 2 minus 2 is 2, N plus 1 minus 1 here is 0. Below 1 I'll do it, okay. 1 minus 1 is 0. I'm just giving you the easier one. N plus 4 minus N is 4. Now what do we get when we subtract these two? That is, when we are doing C2 minus C1, we will encounter N plus 2, N plus 1 by 2 minus N minus 1 by 2. So N plus 2, N plus 1 by 2 minus N minus 1 by 2. So you can take 2 here. Now let us do this. N plus 2 into N plus 1, N square plus N plus 2N plus 1. 2N plus 2, sorry. Then you have N square minus N here. And then we have a negative sign, so we'll just open it. N square minus N it is. So let us open it. n square plus 3n, 2n plus 2, n is 3n plus 2 minus n square plus n. So n square gets cancelled. You get 3n plus n is 4n, 4n plus 2 divided by 2. You can take 2 common, and it will be 2n plus 1 divided by 2. 2 gets cancelled. You get 2n plus 1. I hope you got the idea how this 2n plus 1 has come. Now when we do C3 minus C2, first and second row, you know already how the value will come. But the column 3 minus column 2, this is column 3 minus column 1. So that is going to be n plus 4, n plus 3 by 2 minus n minus 1 by 2. Same thing you have to do. You have to open it and see what comes. It will be 4n plus 6. You will see just now. So n square plus 3n, multiplying 4n plus 4 is 12. And then minus, same thing which we did just now, n square minus n. Now open it, n square plus 3n, 4n is 7n plus 12 minus n square plus n. N square gets cancelled, 7n plus n is 8n plus 12 divided by 2. You can take 2 common from here, you get 4n plus 6. So 2 gets cancelled, 4n plus 6, this is the answer. Now let us open it using the first row. First row, so 0, 0 is there. We'll open it using first 1. I'm not using the other zeros, so just 1. 2, 2n plus 1, 4, 4n plus 6. So what do you get? 2 into 4n plus 6 minus 4 into 2n plus 1. So you get 8n plus 12 minus 4 to the 8n minus 4. So 8n gets cancelled. 12 minus 4 is going to be 8, and that is going to be your answer. Third is your answer. Okay, this is all about this exercise. Thank you so much. Take care of yourself.